Alright, following up from the last video on parameterizing circles, we're going to look at question 5 on the worksheet. Part A says, find a parameterization for a particle moving clockwise around a circle of radius 15 centered at the origin such that the particle makes one complete trip in 20 seconds. Alright, so you see the circle here, radius 15 centered at the origin. The particle is moving in a clockwise fashion and it completes one trip around in 20 seconds. So based off our discussion in the last video, this implies that the period of the sine and cosine waves for our x and y coordinates, which is 2 pi over omega, that's equal to 20 seconds. And so this implies that omega is pi over 10. All right, and since the radius of the circle r is 15, also based on our discussion in the last video, okay, one way to parameterize this circle is to set x equal to r, so that's 15, times the sine of omega t, so pi over 10t, and y to be 15 times the cosine of pi over 10t, and here t varies over the interval from 0 to 20 seconds. So first note that when t is 0, x, which I've sketched right here, is equal to 0, and y is 15. So that puts us right here at the point 0, 15, at the top of the circle when t is 0. And by this choice of omega, we know we complete one trip around the circle in 20 seconds. Okay, now recall in the last video why this choice, setting x to this sine wave and y to this cosine wave, gives rise to a clockwise orientation. Well, as we can see here in these graphs, x starts at 0, and then in the next few moments, x will increase, meaning we're moving to the right of our starting point. And y is going to decrease in the next few moments, meaning we're moving down from our starting point. So we're going to move to the right and down, and that's describing a clockwise orientation. All right, now let's go ahead and check this on Desmos. So you see the equation of the circle here, and then this is the set of parametric equations, right? And I've just used A there for my tracing point. So when A is 0, you see we're at the top of the circle. And now as I let A run through the interval from 0 to 20, we see that we're moving in a clockwise manner and we complete one trip around in 20 seconds. So it's working. Great. All right. So now one comment here before we press on to part B. Now no initial position is stated in part A. Okay, so this is one possible parameterization, but there are others we could have given. For example, I could set x to 15 cosine of pi over 10t. If I do that, then I need to set y to negative 15 times the sine of pi over 10t, and t again runs through this interval from 0 to 20. So when t is 0, now x is 15 and y is 0, so that's going to put us right here at the point 15, 0 when t is 0. Okay, and our value for omega is still pi over 10, so we're going to complete one trip in 20 seconds. And by this choice of cosine for x and then a negative sign for y, okay, this will give rise to a clockwise orientation because notice x starts at 15 and then in the next few moments will decrease, meaning we're moving to the left, and y, since it's a negative 15 sine, it will also decrease in the next few moments, meaning we're moving down. Okay, so we're going to move to the left and down, and that's giving us a clockwise orientation. And we can check that answer here. So this point in green, right, I've just entered in those parametric equations. So when I hit play, I can see, again, we're moving in a clockwise fashion, and we complete one trip in 20 seconds. So it's working. Great. All right, so let's check out part B now. It says, same problem as part A, but now the circle is centered at the point 25, 30. Okay, well, the idea here is just to shift the center of the circle from the origin to the point 25, 30. And that's as simple as, so here's the circle, that's as simple as just taking, and you can take either one of the answers here. I'll just take the first answer we gave, and then just shifting, so in other words, adding 25 here for x, and then adding 30 here for y, and that's just going to move our center from the origin to this point 25, 30. Okay, so let's check that out on Desmos. So here is our circle, right, centered at 25, 30, and then just entered in the parametric equations here. And now as I let A run through the interval from 0 to 20, first off note that when A is 0, I'm again at the top of the circle, which this point would have coordinates 25, 45, right? Because the center's at 30 and the radius is 15. So this would be the point 25, 45. And now if I hit play, I can see again I'm running around in a clockwise fashion and I complete one trip in 20 seconds. So it works. Great. All right, and then for part C, it says describe the curve x is equal to -4 sine of 2t and y is 4 times the cosine of 2t. And here t varies over the interval from -pi/2 to 3pi/2. All right, so I need some space for part C. All right, so first off, note that since omega is 2, the period of each one of these waves is 2 pi over omega, so 2 pi over 2, which is just pi. Meaning what? It means that we'll complete one trip around the circle in pi units. All right, now over here, I've just constructed a table of values, okay, to help us just track where we're located at various times. So at our initial time, when t is -pi/2, just plugging in, we get that x is 0 and y is -4. Okay, so that's going to put us right here at the bottom of the circle when t is -pi/2. All right, now if I go up in increments of pi/4, so from -pi/2 to -pi/4, plugging in again, I get that x is 4 and y is 0. So that puts us right here at the point 4, 0 when t is -pi/4. Now go up another increment of pi/4, so when t is 0, x is 0 and y is pi/4, so that's just going to put us here. And then when t is pi/4, we're here. And then when t is pi/2, we've made one complete trip. Okay, so notice this is our starting time at -pi/2. And then in pi units, so in other words, when we're at t equals pi/2, we've just returned to the bottom of the circle. All right, now if I go from pi/2 to 3pi/2, well, that's another pi unit. So what are we going to do? We're just going to make one more trip around the circle. Okay, so we do that from pi/2 to 3pi/2. That's just going to send us once more around. And in summary, we see that we're located at the point 0, -4, so at the bottom of the circle when t is -pi/2, and we traverse the circle of radius 4 centered at the origin twice, moving counterclockwise as t varies over this interval. And we can easily check the answer there. Just plug in the parametric equations. Here's our interval for t, here's our tracing point, and if I let A run over this interval, let's see what happens. Now note when A is -pi/2, I'm at the bottom. And now as I hit play, there's once around and twice around. Okay, so that's going to do it for this video. I will see you next time.